Okay, if the problem looked like this, I could write tangent squared over tangent squared, and that is equal to 1. But the secant doesn't have a squared on the bottom. Okay? So what I'd like you to do is take out your notes that look like this. Okay, and let's look at that sheet. And on that sheet, we will try to find something that we can kind of plug in. Okay, look at this bottom piece right here. Okay, do you see, as you look at this bottom piece right here, that we have a secant of x minus 1? Everybody see that? And it's paired with a secant of x plus 1. Where does that come from? It comes from secant squared minus 1. Finally, where does secant squared minus 1 come from? Tangent squared, right? So watch how I can simplify this problem. I will simply use that piece. Tangent squared could be rewritten as secant squared minus 1. Now, according to our notes, how can you rewrite secant squared minus 1? Yeah, secant squared, secant minus 1 times secant plus 1. So I have secant minus 1, secant plus 1, all over secant minus 1. What happens? Which ones cancel? That piece cancels with that piece because it's written as multiplication. So the answer is secant minus or plus 1. B is kind of similar, isn't it? Cosine plus 1. It's not a cosine squared, it's just a cosine plus 1. So let's look at our notes. Do you see a cosine plus 1 somewhere? Right here, right? It comes from a 1 minus cosine squared. Where does 1 minus cosine squared come from? It comes from sine squared. Do you have a sine squared in your problem? Yeah. So I can write this as cosine of theta plus 1 over, instead of writing sine squared, what can I write? 1 minus cosine squared. What can you do with 1 minus cosine squared? Yeah, expand it to. What do your notes say? 1 minus cosine and 1 plus cosine. Is cosine plus 1 and 1 plus cosine, are those the same? Yeah, it's okay to move addition around, isn't it? Is it okay to do that with subtraction? No, but addition it is. So I can take these and I can cancel them. And so you have 1 left in the numerator and the denominator 1 minus cosine. And that's as simplified as you can get. Doesn't simplify. Doesn't simplify. That divided by that is 1. Okay. With C, there are no squareds, are there? As you look at your sheet right here, There's a lot of things you can substitute as long as you have a squared. If you don't have a squared, there's not many things that we can really substitute. So, A for the day, what could I do to get a squared? It's already factored. Distribute. Secant times secant is secant squared minus I like the secant squared, don't you? Right? I like it, do you? But I don't like the secant cosine. What is secant in terms of sine and cosine? And what's 1 over cosine times cosine over 1? 1, right? So we have secant squared minus 1. What is secant squared minus 1? Tangent squared. Not easy, right? We'll continue to practice. Hey, look at D. I have sine times sine plus cosecant times cosine squared. I've got a cosine squared, but I don't really like the cosecant that's attached onto it. And I have a sine. I'd rather have a sine squared. So what do you think I should do? Let's distribute and see what happens. What's sine times sine? Can I show you a shortcut? Remember before we wrote this secant of theta times cosine of theta? What's the relationship between secant and cosine? They're reciprocals, right? What do you get when you multiply two reciprocals? You get 1. What's the relationship between sine and cosecant? They're reciprocals. So we multiply, you'll just get 1 times cosine squared. Hey, I've got some squareds. You recognize that at all? We've used it many, 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 many times. We used it earlier this year in section 1.3. We used it just earlier this week in section 2.1. We've used it. It's sitting right in front of your face, right on your notes, right next to number 5. 1. Do you remember this formula? Sine squared plus cosine squared is 1, right? We've used it many times. It's sitting right here. Sine squared plus cosine squared is 1. That's it. Okay. All right, flip it over. You like that one, don't you? Hey, this is similar to what we did yesterday for the what do you want to call it? The extra credit. Um, I don't have a squared. I'll multiply it out. 1 times 1, 1. 1 times cosine, cosine. Negative cosine times 1, and negative cosine times positive cosine. Whoop. Sorry, folks. Negative cosine times positive cosine, negative cosine squared. What happens to the pieces in the middle? They go away. They take a vacation to Hawaii. And we're left with 1 minus cosine squared. Oh, hey, what is 1 minus cosine squared? F. What should I do? Distribute. Tan times tan. Tangent squared. Tangent times negative secant. Negative tangent secant, right? Secant times tan. Positive tangent secant. And secant times negative secant. Negative secant squared. What happens in the middle? They go to Cuba. Hey, I got a couple squareds. That's good news. Do you see tangent squared minus secant squared in your notes? I think I see that secant squared minus tangent squared is 1, right? So you can't flip the negatives, can you? But can I show you a trick? If I were to factor a negative 1 out of this, this negative secant squared would turn to positive secant squared. And if I factored a negative 1 out of tangent squared, it would turn to negative tangent squared. Oh, now I see that on my sheet, right? What is that? 1. So the final answer will be negative 1. Okay, a couple more. We won't do all these, but we'll do a couple more. What should I do here? Continue to multiply out. 2 secant times 2 secant is 4 secant squared. 2 secant times 2. Negative 2 times 2 secant. And negative 2 times positive 2. What happens to the middles? Isn't that great when the middles cancel? Go to China. We got 4 secant squared minus 4. Uh-oh. I don't have a 4 secant squared minus 4 in my notes. What do I have that's similar to it? Yes, if you look at your notes, you have a secant squared minus 1. So how can I make this look like a secant squared minus 1? Factor out the 4. What's secant squared minus 1? So I got 4 tangent squared. Ick. No squareds, huh? No squareds at all, right? What if I wrote this as cosine of theta over 1 times, how do you rewrite tangent? Sine over cosine. What's going to happen to those cosines? Ooh, isn't that nice? Plus, how do you rewrite cotangent? Times cosine over 1. A couple really nice things happen here. First of all, what happens to the cosines? So we get sine of theta over 1 plus, what happens here? You get a squared. And getting squareds is a good deal, isn't it? It's a really good deal. Because, no, I can't cancel over addition. I can't cancel over addition. That would be voodoo math. You can't do it. Sine, sine? No, because addition. Okay, if it was multiplication, you could cancel, but not with addition. If we watch, I know you may not like this right now, but trust me, you're going to like it in the end. I have two fractions. One's got a squared. I like that. This one doesn't have a squared. What do you need in order to add two fractions? What is the common denominator between sine and 1? So I'm going to multiply top and bottom by sine. Oh, hey, look, what do I get? I like sine squared plus, what's in the numerator of the other fraction? Cosine squared over, what's my denominator? Sine of theta. Not sine squared. Our new denominator is sine. What is sine squared plus cosine squared? This is 1, right? What's 1 over sine? Secant. I promise that is by far and away the hardest problem that you will see in our course here. Are there harder problems than that? Without a doubt. Letter I follows very, very similarly to what we just did. What I would like you to do right now, see if you can try to set I up to follow very similarly with H. Try to do it on your own now, and then we'll finish the rest off after that. Okay, go ahead. Okay, a few people got it. Answer secant. Okay, first step was to write it in terms of sine and cosine. Does anything cancel? Nope. So I have sine squared over cosine plus cosine over 1. Hey, I like the sine squared. Wish I had a cosine squared. Do you get one? What's sine squared times 1? Sine squared. What's 1 times cosine? 1 times anything is itself, so we could just get rid of 1. Now, I need a common denominator. I'll multiply top and bottom by cosine. Got sine squared plus cosine squared all over cosine. Hey, what's sine squared plus cosine squared? 1. 1 over cosine is secant. On the bottom? Nope, just like if you had 1/2 plus 5 halves, that would give you 6 halves. Right? We leave the denominator alone with fractions. Okay, 3 more. I changed my mind. 1 minus cosine over 1 times sine over 1 times, what about tangent? Sine over cosine. So the reason why I wrote it like this is because I knew tangent would be a fraction. So I wrote them as over 1. I don't want to change them. I just want things in terms of sine and cosine. And I looked ahead in the problem, and I saw that I have a cosine in the denominator, and I have a cosine in the numerator. So when I looked at this, I said, oh, there's a cosine in the denominator of tangent, and there's a cosine in the numerator right here. So I saw that what's going to cancel? Cosine is going to cancel. Furthermore, we get a 1 minus sine squared. Hey, I like squareds. It's a good deal because I often can substitute something. What on your sheet does it say 1 minus sine squared is equal to? So Cass, you asked the $1,000,000 question. How did you know to? Sometimes it's just a matter of looking ahead and seeing, what if I did it? And it's okay to try something if it doesn't work out, to go back and try another route. But unfortunately, you don't know every single time what the right thing is to do. Okay. Uh-oh, in K, I feel like I have too many squareds. I'd like a 1. How can I get a 1? Special word starts with F. Very good. If I take a cosine squared out of cosine squared, I'm left with 1. Plus, if you take the cosine squared out of cosine squared cotangent squared, you're left with cotangent squared. Hey, I like that. What is 1 plus cotangent squared? Very good. I like cosine squared times cosecant squared because that looks like something that we did on the very first day, right? That's cosine squared over 1 times 1 over sine squared. What is cosine squared over sine squared? Cotangent squared. Last one. What should we do with the cosecant on the outside? Distribute. See if you remember, what's the relationship between cosecant and sine? They are reciprocals. If we multiply two reciprocals, we get 1. So we get 1 minus 1 times cosine squared. I like it. I got a 1 and a squared. Good chance I can substitute something. What's 1 minus cosine squared? Sine squared. I don't pretend. Guys, I don't pretend that this stuff is easy. Okay, guys. 6 problems. Okay. I will tell you that some of the problems in your assignment are identical to the problems we did in our notes. Well, what you should do is you should try them on your own, and then if you can't get it, look back at the notes and see if the notes gives you a hint. So again, just do your best. Tomorrow you will get a worksheet that practices kind of all 3 steps that we've taken over the course of the next couple or last few days. So we will not have a test before break, but you will have a test when you get back. And when you get back from break, the tough thing about your test is final exams will happen pretty quickly after that test. So I would not count on saying, oh, well, I could just retake the test if I don't do well. you really want to do well on this one the first time because some of you are still retaking the last test. So you want to make sure you kind of get your ducks in a row and um, feel good about where we're at. So tomorrow's a big day to check to see where we're at.